This next section is about arithmetic sequences and series, right? Not arithmetic, arithmetic. Arithmetic sequences and series.
That's good.
Arithmetic sequence is just a list of numbers that go up every time, right? So we've got a formula right here that defines the nth term for an arithmetic sequence. Okay? It's a sub n equals d. Now d is called the common difference. Okay? This is the value that we're going up by every time. Okay? So d times n minus 1 plus a sub 1, which would be the first term. Right? Now, another way that we can write this, is a sub n equals d times n, that's times n, not sub n, plus a sub 0. Okay, but this version would require us to calculate a sub 0. Okay, so this is the more common form that we'll see. A sub n equals the common difference times the quantity n minus 1 sub 1. Right, now, this can also be defined recursively, where we're just saying to get the next term in the sequence, we take the previous term and add the common difference to that. Okay? So, if we look at a few examples here, where we are asked to write our formulas given a list of terms, given the sequence. Well, I need one piece of it, the common difference, in order to use this formula. So the common difference time. In this first example, I would be adding 4. Every difference for this is 4. So to write my explicit formula using this pattern, we're going to say this one is going to be a sub n equals the common difference times n minus 1 plus the first term. Right. And we can test to make sure that this works to get these values. Okay, if I plug in 1, I should get 3. So if I plug in 1 for n, 4 times 1 minus 1 is 4 times 0 plus 3 gets me 3. If I plug in 2, 4 times 2 minus 1, so that would be 1. 4 times 1 plus 3 is 7. So this formula works to get me every number in this list. If I wanted to write this recursively, my formula, I would just write this as a sub n plus 1 equals a sub n plus my common difference. Okay, so recursively, this is just saying to get the next term, take the previous term, and add 4 to it. Okay. Questions? Let's do one more together here. So on B, I've got negative 6, negative 21, negative 36, negative 51. So again, the first thing I need is my common difference. What value am I adding every single time here to get to the next term? Negative 15. And I'm adding negative 15. So to write my formula, this is going to be a sub n equals negative 15 times n minus 1 plus my first term. So plus negative 6, or we could just write that as minus 6. Then my recursive formula, write that as a sub n plus 1 equals a sub n minus 6. But we could write it as plus negative 6.
No, I don't understand.
So the recursively defined part, or are you talking about this part?
No, I understand that. I just don't understand.
Okay.
We're getting the last one.
So the recursively defined function is just saying to get the next term, take the previous term and subtract 6.
Shouldn't it be 15?
Oh, yeah, sorry.
Oh.
Yes, it should be.
Thought it was picking up on something.
Yes, the common difference is what should go there, not the first term.
So the first term would just be -6.
That sounds so wrong.
Yeah. So to use the recursive formula,
So wrong.
we would say, well, if I know the first term is -6, to get the next term, I would plug -6 in here. So to get the second term, I would plug the first term in. -6 minus 15 is -21. Right?
So we're
Questions on that?
You're
All right, we're going to skip the next two examples just for time's sake here. So if we jump down to example 2, here, we are given two terms in the sequence. Okay, I'm given that the fifth term is 15 and the 20th term is 45. And just from that, we want to write our rule. Okay? So we want to use this formula. A sub n equals d times n minus 1 plus a sub 1. Okay, well, the pieces of information that I know the fifth term is 15. So what that tells me, okay, so this is like saying a sub 5 equals 15, and then the 20th term is 45, so that's like saying a sub 20 equals 45. I want to plug both of those pieces into this rule separately. I'm going to create two equations, and then I'm going to solve this system of equations. So, if the fifth term is 15, what I can do is say a sub 5 is 15 equals d times 5 minus 1 plus a sub 1. Okay, so I'm saying n is 5 here. 5 is my fifth term, so that's my n value, and then a sub 5 is 15. Okay. Now I can simplify this and just say this would be 15 equals 4 times d plus a sub 1. I'm going to do the same thing with this piece of information. Okay, I'm going to come over here and say, well, my 20th term is 45. So 45 equals d times 20 minus 1 plus a sub 1. And again, we can simplify this to just be 19. So I can say 45 equals 19 times d plus a sub 1. So now I've got a system of equations. And I'm going to rewrite this one over here underneath my other. How would I solve a system of equations like this? Okay, my two variables, my two unknowns are d and a sub 1. What's that? Set a is on the same side. So that would be one way to do it. We could subtract the 4d over, subtract the 19d over, and then set those two things equal. That's what you're thinking? Yeah, that would absolutely be one way that we could do this. All right. So we can go ahead and do it that way if we would like. So elimination. Right. So I can multiply one of these by -1 to get these to cancel out. Why are we doing what? To solve for a missing piece. Okay, so if we do it Alex's way, I would subtract that over to get this equal to a sub 1, subtract the 19d over. Okay, so now since I have both of these things equal to a sub 1, I can set them equal to each other. So we can say 15 minus 4d equals 45 minus 19d. So get the d's on one side. So I can add 19d over here. So that'll be plus 15d, subtract 15 over, divide by 15, and we get d equals 2. Okay, so that's one way to do this. Remember, we could have also used elimination, multiplied one of these by -1, added the two equations together, and then solved for d. Okay, so now I still need my first term to write my rule. Right, so what I can do is take this value and plug it back into either of these equations. So I can say 15 equals 4 times 2 plus a sub 1. So 15 equals 8 plus a sub 1. Subtract the 8 over. We get that the first term is 7. So now I can finally write the rule for the nth term. By using this pattern, I can say that a sub n is equal to my common difference times n minus 1 plus my first term. Okay, so what we're doing here, we're using each of these pieces to create a separate equation and then solving that system of equations. Okay. Questions on that? Alright, then on the back, let's take a look at series. So, an arithmetic series is just where we're adding up all of the terms in an arithmetic sequence. This formula right here, okay, lets us do that. The sum of the first n terms in an arithmetic sequence is equal to the number of terms times the first term plus the last term divided by 2. Okay? The reason that this formula works, okay, let's say I wanted to add up all the numbers from 1 to 100. Okay, well, what they're doing, okay, they're saying if I group these terms, so if I listed all the numbers first from, I can write a couple more out, I suppose, 1, 2, 3, all the way up to 50, and then came over here and started listing the rest of them backwards. Oops, starting with 100, and then 99, 98, down to 51. If I group the terms like this, and I add 1 plus 100, that's 101. If I add 2 plus 99, that's 101. If I add 3 plus 98, that's 101. If I do that all the way down to 50 plus 51, that's 101. Right? So if I'm grouping all these numbers in this fashion, the first in my sequence plus the last, I'm doing that n over 2 times. So if I'm adding all the numbers from 1 to 100, I'm actually adding 101 50 times. 100 divided by 2 times. That's where this formula comes from. Okay, so another way of writing this is n over 2 times a plus 1 plus a sub n. Right, so I'm just adding the first and the last term, and then doing that 50 times in this case, because I'm adding the numbers 1 to 100. So it's just the number of terms divided by 2 times the first term plus the last term. No, we're not going to write it 25 times. I'm just showing you where this formula comes from. Right? So we can do a couple examples here. To use this formula, I need a few pieces of information. I need the number of terms, the first term, and the last term. So here, I actually, just looking at this, I don't know how many terms are in this. I know what the first term is, and I know what the last term is. Right, so I can write this as something over 2 times 1 plus 25. Right? How am I going to figure out how many terms are in this sequence? Something with 3?
Yeah, I swear.
Well, so we can see the common difference is 3.
Yeah, I get to use that to find out how many terms there are.
We can. How?
Divide. Maybe.
Yeah. Kind of. We just talked about. Okay? In this formula, I know, I can see the common difference. So the common difference was 3, and I know the first term. So I can write my rule as a sub n equals 3 times n minus 1 plus 1. So I want to figure out which term 25 is. So what I'm going to do is put 25 in here for a sub n, and then solve for n. Okay? Subtract 1 over, divide by 3, and then add 1. So that tells me that 25 is the 9th term in this sequence. So this is going to be s sub 9 equals 9 divided by 2 times 26.
Let me write down all of this stuff.
Okay. I'll make a short head puzzle to finish out these notes. Okay, and then